Hello, everybody. Thank you for joining us for today's webinar, all about the UNS Plus. And that means how do we add historic data access and analytics with governance to your UNS? My name's Jeff Nepper with Flow Software, and I'm here with my partner, Leonard Smith. Lenny, how are you today?
Good and you, Jeff. Thanks a lot for inviting me to join you on this webinar today. Hope we've got some insight that we can learn and educate the crowd on the UNS Plus.
That's right. And so many of you might be wondering, UNS Plus, I haven't even got the UNS figured out yet. Don't worry. It's really just how do we take the UNS and feed it better information that has governance, the analytic, and how do we add historical data access from all of the data sources you already have on the plant floor. So today our goal is really to help you take your disconnected operational data, making it easy to manage so you can use it and stop wrestling that data to try to find insights from it. Instead, we want to show you an easy way to take what you already have without having to go to the cloud, without having to build some new database inside of a new service provider inside of AWS or Snowflake or Azure, but really take care of the operation side of the business. In our experience, most of the manufacturers around the world have been collecting a lot of data for quite some time. And we want to show you how to take that data and really make it work for you, empowering your decision makers, driving your reporting tools, and just making sure that you have the most up-to-date information that you can trust at all times. So during the demo, that's exactly what we're going to build. We're going to show you step-by-step how you do that in Flow, how you connect to your existing historians, your existing MES, your quality and LIMS, your CMMS, and so forth and so forth. At the end of the demo, Lenny's going to show you then how to take those new insights and analytics and publish them to the UNS, just like we did at Prove It 2 weeks ago. But we're going to slow it down a bit. We have a little more time today. We are still offering pilots for the remainder of this year. We were blessed and ended up with 9 pilot opportunities as a result of Prove It. So our Q2 and the first half of our Q3 is now fully booked, but we are going to give you an opportunity, if you like what you see, to start a discussion around a pilot for the end of Q3 and Q4 still yet this year. All right, Lenny, with that, I think we should just first talk about what are the data sources that we're going to connect to today. And it might help, Lenny, if I start off by sharing my screen. Webinar Fundamentals 101. Hey, speaking of webinar fundamentals, let's do a little housekeeping. There is a chat. Feel free to use the chat to make comments back and forth, talk amongst yourselves. We will monitor the Q&A for questions throughout. So if you have a question, feel free to throw it in the Q&A section, and we'll try to answer them if they make sense in stream, and if not, we'll save some time at the end for your questions. Sound good, everybody? Well, then let's get started. So Lenny, when we talk about the databases that we're going to connect to, really it's what a lot of the manufacturers already have. So our assumption is that you probably already have a time series historian. It may not be any good. It may be out of support, tough to get data out of. Fair enough. We'll talk about that. But Flow uses standardized technology and protocols to connect to all of the legacy historians. So we provide out of the box an OPC HDA and an OPC UA connection for historical data. We then also develop custom plugins for the more popular historians that allow us to increase performance or take advantage of some special feature sets by developing a custom connector, typically against their API or an SDK. So we've done that for quite a few historians, notably Ignition's historian, which is always a bit problematic because of the way they do monthly partitions. We take care of all of that in the back end to make it really easy. Maybe you don't have a historian. And Lenny, I think in your experience, you have run into customers that if they don't have one at all, maybe they're just getting started, or the one that they have, frankly, is just no longer operational. Talk to the group a little bit about what we've released recently and how they could take advantage of that.
Perfect. And it's also true to what we've seen with obviously the UNS. It's a place to land your real-time data, but I need a place to historize that real-time data to create my analytics and aggregations on that. So we've came across this quite a lot where people want to start with the information journey, but obviously they're lacking a little bit of data, historical data, to start on that journey. But the need for information and the need for KPIs is still there. So we have released a free historian, time series historian, that will be able to collect data from an OPC UA server or an MQTT broker. It supports basic JSON payloads as well as Sparkplug-B. It's a NoSQL technology, so we utilize flat file storage to store the data. And you can get the data out via a trending tool. So it's got a complementary trending tool with it, as well as a feature set of APIs, rich feature set of APIs to manage, to get the data out, and to utilize it in other applications as well. It's called Timebase. You can go and have a look at timebase.com. And yes, it is free. So the main historical part, or the main purpose of the historian, to historize data for analytics, will be a free product.
That's right. So feel free to take advantage of that if you'd like. We've actually already had almost 800 downloads and installations since December 18th when we released it. So we're getting great feedback, and we will continue to support this product. So that means free support as well for any type of problems you run into along the way. We will continue to version and release patches and bug fixes. And right now we're working on version 1.2 for the historian. So we're super excited about where this product is going. Okay, so Lenny, if we've got the historians already taken care of, what about all the other databases, the SQL databases, the real-time? How do you typically connect to those?
Well, most cases, and the example of the demo that we're going to do, is there's a lot of MES related data that would sit inside of some sort of transactional database, right? Mostly of those are SQL based databases. What we've done with Flow is, again, we utilize .NET technologies to utilize and create plugins for those different databases. So we do have plugins for Microsoft SQL. We've got plugins for Postgre, MySQL, Oracle, Snowflake, all to get that transactional data out and to kind of merge and marry them together with the time series data to really create insight and context and add additional context to your data. All done in the same tool within Flow. You'll create the connections to all of these different data sources so that you've got one place to access them all, and then one place to create your calculations and aggregations from.
Perfect. And Lenny, today when you are doing your demo, you're really kind of actually starting the way that we started most of our pilots, right? We get to know the team. We try to understand what knowledge they feel like they're missing from their process, or what type of insights or KPIs or events they'd like to increase their visibility on for their reporting. Typically, that's how we build a pilot. Now, from stage at Prove It, I believe you focused on some production forecasting. Am I already forgetting? It's been 2 weeks.
No, that's 100% correct. We focused a little bit on production, just to get a very simple use case of total production per product. And 100%, Jeff, it is based on a business use case, what the KPI is and what that KPI should drive within the business. Because at the end of the day, we want to make decision support based on the KPI to drive that driver in the business either up or down, depending on what that KPI is. I think for today's use case, let's focus a little bit about utilities. So utility consumption. Let's see how we can utilize the tool to get data from multiple data sources, focusing around power utilization, and see how we can potentially create a few KPIs to help drive power consumption within an organization, marrying data from historical data sources as well as then the MES database as well.
Okay, perfect. And really, Lenny, what you're demonstrating today is the first part of how we engage with a pilot, what we actually start building for the customer. Usually you build, or somebody on the team will build 80% of the project, and then work with the customer on the remaining 20% to transfer knowledge, get feedback, produce the finalized reports, understand where to feed the data inside the organization. Typically, you spend about 60 hours, I think, or someone else on the team will spend about 60 hours in that process, 3 to 4 weeks after the IT department has actually given you a VM and some access. And that's a $20,000 package. The customer keeps the license, which I think is super important here. You walk away with a flow system that's yours forever. So we'll give you more information on how to book that at the end of the webinar. Lenny, I think that means we're ready for you to build. You've told us the challenge you're going to solve. You're going to do some energy use per state, build a production report with the energy tied in. At the end, will you show us how, from a solutions architecture, enterprise architecture, how to then take that data and move it around the organization?
Perfect.
And don't forget to scale. How are we going to scale?
Exactly. Okay. So let me share my screen here. All right, let me just paint the picture of what we are building. Some of you guys might remember from Prove It that we had a virtual factory that was simulated within Prove It. And part of the Prove It process was a press. Now, these presses makes little bags where product gets filled into. There's a laminator that actually laminates the bags. And what we're going to focus on today is that press part. So the press is really making the individual bags and pressing them out and putting them together. So we've got our use case, which is utilization. And what was asked from us from a customer perspective is we would like to understand a little bit better of how much energy are we using per product of bag that we are manufacturing, or per type of bag that we are manufacturing. That was one use case. The other use case was, as well as there's certain states that this press goes through in its machine state cycle when it actually manufactures the bags. And there's a certain part of the process that they suspect is using a lot of energy, but they want us to build a KPI to actually track that. So we need a few things, right? We need state information that will be coming from our MES database, and we actually need the real-time energy consumption or meter information that's coming from the production floor as well. All right, so what I've got is the flow config tool shared in front of you guys. Just very quickly, high level, on the left-hand side is where I would model. So Jeff showed that process around collect, storage, visualize and share. Part of the connect aspect is also to model the KPIs and create structure against that. So you'll notice that I've got a way to create a structure and a model for my presses. And inside of the press is all the pieces of metrics and key KPIs and event frames that I would like to measure against. And I'll show you guys how I would build that out and extend the model based on those different KPIs. So that's the modeling part. That all happens in the left-hand side of the screen. And then connecting it to all the different data sources, that happens all the way here to the right. So in the right-hand side here, I've got all my different data sources. Note that I'm connected to quite a few data sources within this single instance of Flow. I'm connecting to my MES database. I'm connecting to my energy data that's been historized by Timebase from the UNS. And I'm going to use these data sources to get data from. Just to quickly show you guys, the MES database is a MySQL database that they've provided. All the different tables that's in that database. So I've got the scheduling information. I've got the state history for all the states that the machine is in. I've got the area, the cell, the line. So I've got kind of a little bit of a hierarchy of what's been modeled in that MES solution as well. And I'm going to utilize that within Flow to get the data out that is required from me without having to worry too much about SQL coding and SQL statements that I need to go and create as well. So that's the data that sits inside of the MySQL database, mostly MES related data. And then obviously I've got my UNS data that's coming from the broker for the presses that's constantly pushing new real-time data into the UNS as well. All right, now I'm connected to those data sources. So I'm connected to my MySQL database. And the first thing that you notice is when we browse the namespace for that MySQL database, I'm actually browsing the tags in that SQL database based on the hierarchy or the model that's been created inside of that MES solution. So if I look at a press, I can see there's the presses that's been modeled inside of the MES data. And if I look at press 103, there's all the relevant, almost looks like tags now, of data that I'm going to utilize within my solution. So I've got the downtime. I know if the downtime was planned downtime or not. What is the product that's been scheduled to run? What is the reasons for the different downtime? And is the machine in a running or a downtime state per se? Now, how do we do this? We create a definition that understands the schema of that database, and it will automatically go and break down all of these different tags so that you don't have to actually go and write a SQL query to try and figure out the joins within that database as well. So that's our MES data. We also then have our time-based energy data that's now stored within time-based, and that is just the totalizer of the energy consumption per line. If I double click on that tag, it will go and query the historian for that historical data, and I will see that this is a counter. You can see that counter resets back to 0, and then that counter ties or jumps up again as we are producing or consuming energy. All right, so that's the two type of worlds that we're living in: time series data as well as then the transactional data from the MES system. Now, what I'm going to do is I'm going to now extend my model, and I'm going to now actually build a metric to go and track my energy usage. So I'm going to extend my model here by using the icons in the flow zone, and I'm going to add a metric, and the metric is what am I actually measuring? Well, I'm measuring my inner energy usage, and I'm going to go and take all the relevant pieces of information that I need from these sources to create these KPIs, and I'm going to extend my model with those tags. So I literally take the tag from the namespace of the historian, I drag that across into my model, and now that will create a tag within Flow's model. So this will be my actual kilowatt usage. Now, while I'm dragging these out from these different sources, I'm just going to go to my MES database here as well. It's very important to note that Flow does not replicate the raw data that's sitting in these sources. So by dragging over the state tag or by dragging over the product information for the product tag, I'm not duplicating the data. They stay at source. We just query the data for the time periods that we need and require to do the aggregations and cleaning up the tags, and then we move on and only store the result within the Flow database. All right, so I've got my actual kilowatt, I've got the product, I've got am I scheduled to run, I've got the different state that I'm in the MES. The only thing that I'm still requiring is the reason. So what is the different reasons for that machine to be in a specific state? Okay. When I've added this to the model, I'm pretty much done with the data sources. I don't really have to worry about getting the data from the data sources again. I'm now only going to work in the model side to create my different calculations and aggregations. All right, let's quickly have a look at the state of the machine. Now, remember, the first use case was I want to know for a specific state in the process, what is my energy consumption per state? So I can see there's the different states that the machine is going into. This is now the data that it's pulling from the MES database. I'm just going to give it a little bit more time there to see all the data. So there's my machine going through its different states. Now, I would like to know what's the reasons for those states. So I'm going to add the reason from the MES to my data previewer as well. And what this will do is will tell me what is the different states that the machine is in and what is the corresponding reason for those states. So I can see that when I'm running setup, I'm in state 2. And when I'm in state 1, it seems like I'm either in sort of approval to get going or some washdown sequence or state or some downtime state. So there's a downtime. So it seems like state 1 equates to downtime or setup time, and state 2 is related to actual running. Now, I would like to know, the use case is for this wash down parts state. What is the energy usage for that? Because that's where they believe they're using quite a lot of energy, and we want to isolate and see if that is actually true. Now, how do I do that? Well, I can use calculations within Flow on this raw tag level to already filter out specific states from potentially the energy consumption that I'm using. So let's see how we would do that. I'm going to close this previewer here, and I'm going to take my reason, and I'm going to drag it onto the calculator there to create a calculated tag. All right. Now, in this case, I would like to know if I'm in this wash down state. So I'm going to call this my wash down state. Whoops. And what I'm going to do is a very simple calculation here, and that is to convert those string tags into an actual Boolean signal that I know, yes, I am in wash down or not. Now, I can't utilize the value of that tag because it is a string value. So I'm going to go and utilize via my insert menu here the actual string value that I'm getting back from that MES database.
Lenny,
Okay.
can you real quick, just from a teaching moment, that insert menu, there's quite a few things on that. Maybe the audience might want to just quickly know all the other things other than just a value.
Perfect. So remember now, when I'm pulling data from tag information, either from historians or from transactional databases, that tag could potentially have either string values, like in this case, the states of the machines. It could have a Boolean or a double value, if it's more from a time series historian. But I potentially could also utilize the quality component. So historians does mark if the quality of that tag is good or bad. And I could potentially use that to filter out data or to include or exclude data based on the actual quality coming back from that tag as well. We also give you the capability to see the duration between timestamps or points, so that you can maybe do rate of change calculations as well. And then we also have the capability to utilize model attributes. I'm going to do an example of that as well. So potentially if you've got a nameplate rating or something like that that you want to clamp your values to a certain value, we can utilize that in the calculations as well.
So on the duration, would I use that for maybe if I wanted to identify if data was stale?
Potentially you could. If my duration of a point is, because it's the duration from the previous point, so you can see how long a tag is in a specific duration as well. Yes.
Thank you.
Perfect. All right, so let's look at my string value here. So I know that I need to see that if my string value is in this wash down slash parts change, then I know I am in that state. So I'm going to make that a 1. So all I'm doing now is writing an inline if statement just to convert that string value into a Boolean. So if I'm in that particular state, it's going to give me a 1, else it's going to give me a 0. Validate my calculation there, refresh the data, and there we go. So let's just give it a little bit more time. And if I refresh that, it will show me all the times that I'm physically in that washed down state. So I would like to know
the C# that you were.
Yes, this is C#, an inline if statement. We are a .NET house. We do have a capability to write your own functions or libraries, and you can utilize those functions within the expression editor as well. Okay, so now I know I am running in that washdown state. What about marrying this MES data now with the real-time tag data from the time series historian? So let's do it again. I'm going to take my state now, drag it onto the calculator. This is going to be my filtered energy usage because I'm going to filter it out only for that one particular state. Let's open that up. I've already got the washdown state in the expression editor. I'm going to add my kilowatts to this as well. And I'm also going to add the actual state of the machine into this calculation as well. All right, so you guys can see I'm adding in all of these different tags from all of these different data sources. Technically, I don't really care where they're coming from because Flow will normalize the points for me so that I can work with the points within the calculation expression. So now it becomes quite easy. I know that if I'm in this washdown state, so if that state is 1, and I am in a downtime state in the MES, which was also state 1. So if those conditions are true, then what I want to do is I want to return the actual energy usage, else I'm going to return null or nothing. Okay, so again, inline if statement, just building on that equation, filtering it even more based on the state and the specific state that I'm interested in. And if I validate this, it will go and filter out the data and only give me the energy consumption for that particular state. So instead of having all the counter values for all the energy, I only have the energy usage now for that one particular state of the machine when I'm in this wash down cycle. Okay, so that's now based on the raw tags, marrying the tags from all of these different data sources and creating the calculation from that. Now I can go and aggregate it further. And remember, guys, up until this point, we still haven't duplicated the data. These tag calculations are still done in memory on a query basis. I'm now going to create a KPI to say, okay, what is my hourly usage of energy based on this filtered value? And that's the result that we're then going to store within the Flow database. Okay, so let's close that. All I have to do now is take that filtered energy usage, drag it onto my hourly icon in the flow zone here, and that will create a 1 hourly KPI that's going to aggregate every hour. It's going to create a time slice for me for that hour. It's going to query and apply the tag calculation based on that data. Very importantly, the type of data that I'm looking at is a counter that rolls over, right? Yes, we're filtering a lot of that data out, but it's still a counter data point. So I'm going to go and select the counter aggregation. Notice that you could specify the rollover if you know exactly when it roll over, else Flow will automatically pick up that rollover point. And I can also add a scaling factor if I want to convert to a kilowatts or megawatts or whatever the case is. I can scale that value out as well. Very importantly is I can backfill. So you'll notice at the top here that we are backfilling the data to 2 weeks ago. So Flow can already look at the historical data, as Jeff said, that's been stored and historized on your plant floors for maybe even years. We can already backfill and create a baseline of what that energy usage actually is.
And
If
Lenny,
I deploy this,
I think
yes.
Lenny, one of the questions that came through on our Q&A while you were demonstrating was the idea of, from an architectural standpoint, why would we prefer to connect to a database rather than the UNS, since the UNS already has this data modeled? One of the things that we find is that when you're building an analytic, having that history to be able to lean into and be able to not just calculate OEE, but understand historically, how has your OEE been performing? Or how do we know today if our utility consumption is good if we don't have 6 months of data to judge it on? Right, that's right.
Correct.
There's also this concept of, as we're building our information model, we don't expect to get it right the very first time. So by storing the data first and then modeling it, this gives us the flexibility to change that model over time, extend it, have different versions of it as well.
Correct. Perfect. Thanks, Jeff. All right, so there I've got my hourly value stored. I can see what that consumption of energy is for that particular washdown state. Something doesn't look 100% correct for me here. Why do I say that? Well, I've added some static metadata to my model. Part of that is what we call model attributes. So each KPI within the Flow information model can have static metadata associated with it. And part of my metadata is obviously where's the line when I'm running. I'm running for press 3, but I also have this nameplate rating that's associated with my machine. And I would like to clamp the value based on that nameplate. And I can see there's some values that's a little bit over what it should be. Maybe the instrument gave me a wrong reason or value, but I would like to utilize that potentially in a calculation going further down to actually clamp that value as well. So the point here is that, yes, I can filter data and create calculations on that raw tag level where we normalize the points coming from the different sources. But I can also create calculations based on the already aggregated data. So now I can use that hourly KPI and I can say this is my 1 hour clamped as an example. And again, same kind of concept, same expression editor where I go and write these expressions. And now what I can do is I can utilize those static model attribute properties within my calculation as well. Again, I'm going to utilize the insert menu here. And I'm going to say, please add context to my expression. The context that I would like to add is the context of my model attributes. And in this case, the model attribute that I'm looking for is my nameplate rate. Cool. So I'm looking for the context on myself, looking for that nameplate rating attribute, and I'm looking at its value. So now I can build, again, a very simple little expression where I say, well, if the value is greater than the nameplate rating, this nameplate rating is a string, so I just need to convert it to a double for that comparison to work. So I'm just going to do a very simple system.convert to double, again, C# expression that we do here. And that will then give me the value. So if my rating is greater than my nameplate rating, again, let's ask the question inline if statement, then return the actual rating, else just return the value itself. Validate and deploy it out. And now we should not see a value that's greater than 3000 as we're going to clamp it to that point over there. Right, so now I've clamped it to keep within my nameplate rating as well. Great. So now I know energy consumption per washdown state. I've got history of that KPI, so I can now see how that KPI changes through the day, through the week, through the year, and I can now monitor that KPI and see if I can drive that cost down. What if I want to now know energy consumption per product? So that was the second use case, is how do I now get the product information and slice and dice my energy consumption per that? Well, with that, we need to go and create what we call an event. All right, so up until now, I've created hourly slices of time. Now I need to create slices of time for the entire production run or when I was scheduled to run, so that I can get energy consumption per actual run of a specific product that I'm pushing through this press. So again, I'm just going to add my event to my folder here. This is going to be my product run event, and I'm going to utilize the schedule information from the MES database to track this event frame. So I'm going to go and add my scheduled tag as a trigger. So when I'm scheduled to run, I will go and trigger this. When the schedule is over, I will end the trigger. So this just tracks how long that schedule is going to run. And then I can add some attributes. I can add what is the work order or the product that I'm actually running on this line as well. So I'm going to quickly create a new attribute that we are retrieving again from that MES database. And in this case, this is going to be our product information. And I'm going to use the product tag to get that context out as well. Again, same concept. We can backfill, flow will run through and give me that historical data as well. Now, in this case, I don't want to use the filtered values because the filtered values are only for that one particular state, which is the washdown state. I would like now to get all energy consumed for the entire run. So I am actually going to use the raw data source tag again. I'm going to drag it onto the hourly icon. This is going to be my 1 hourly counter retrieval of energy consumed. But now what I'm going to do is I'm not just going to have context of the hour. I'm also going to have context of my run. And the way that we do that is we add that production run as context to my KPI as well. And I can add the metadata for that as well to say what is the product. And now we will slice it not only per hour, but slice it for the entire product run duration as well. Again, deploy that out, engine will backfill, get all the historical data. And now what it's going to do is it's going to use these triggers that it's created for the schedule when I'm scheduled to run. It's going to look in the MES database to see what is the actual products that was scheduled to be run as well on that machine. And it's now going to slice it and give it to me for all of the hours. I can see what is the actual product that's running. I can see what is the consumption per product, and I can also see the consumption per individual run as well, how much consumption that is. Cool, that's great. What if I want to aggregate this even more? What about aggregating this to tell me for the entire week, which product used the maximum amount of energy? Okay, so I can take my event context and I can even aggregate the event into higher time frames as well. We call this secondary aggregations. So I can take my production run event, drag that on the weekly icon, and this is going to be my weekly max energy usage. And it's going to be sliced by product. So if I open this guy up, I can now say, you know what, use the product run event. Go and look for me for all the events that started in the week. Okay, so that's the rule. At least it has to start in the week. And then go and aggregate for me all of my hourly usage of kilowatts. Okay,
Lenny,
now,
how do you define your week?
Week is defined within the calendar, Jeff. So Flow has the capability to go and define calendar settings where we specify a start of a day, start of a week, start of a year, so that we talk about days and weeks and years, that we know a week is from either a Sunday to a Sunday or a Monday to a Monday. So that has all been predefined within Flow's calendar context as well.
And if we wanted to run production week or year versus financial, or if we wanted to look at shift patterns, you would do that as well?
Yes. It's all defined in the toolbox for the calendar. Let me finish this small little piece of config, and then I'll show you guys that as well. All right. Now, I could have said what is the total energy usage for the week. In this case, I want to really figure out which product is causing me the heartache. So I'm going to look at what is the maximum for the week, energy consumption wise. And again, I'm going to add the context for the product into this as well, so I can get that product information. Deploy this out. And what it now would do is for the entire week, go and create a point for me and add the context so I can see for that week what product was actually utilizing the most energy for the week as well. Okay. Let's quickly touch on the calendars that Jeff mentioned. If I go to my toolbox, expand my calendars, I've got my one calendar currently, which is my production calendar. In this calendar, I can go and configure the settings to say what year, what month does my year start in, what day does my week start in, and when does my day start, in this case, 6 o'clock in the morning. And yes, I can associate a shift pattern to this. So I've got my shiftly context that I can add, and I can go and create more than one calendar, physical calendar versus a financial, or a production calendar against a financial, and then have the two aggregation methods apply to that as well. Cool. So I've got context for the energy usage per product, per week. I've got context of the state, which is my watch down state per hour. What if I want to know how's that tracking from a day's perspective or yesterday? So I can go and create the hourly filtered value and literally just drag it onto the daily icon, and that will then create a daily sum or total. And I'll deploy that out. The engine will go and create a total for the day. I can also look at relative time periods. So if I would like to know what was my moving average of consumption, what I can do is I can go and drag the hourly consumption again onto the calculator icon. And now I can say, go and create a 7-hour moving average. And instead of looking at the current hours values, I can now go and look at a whole range of values. So in this case, I'm looking back in the flow database of all the hours that we already contextualized. And I say, you know what, give me the past seven hours worth of values. And now I can do a moving 7-hour aggregate on top of that. So I can use that array of values, and let's do a average on top of that to get me a total of a moving average for the past 7 hours. Deploy that out, and again, the Flow engine will go and create context for that. So now I've got a 7-hour moving average, and I can see how my consumption is tracking against that. So let's pop that one out. So there's my moving average. Drag the original one in there as well, and now I can see how I'm either tracking above or below my moving average. Obviously, those 2 hours were not great. I'm above the moving average, but I'm seen to tracking below the moving average here, which is great. Okay. So you guys can see from a few points, in this case, a little bit of data, contextualized data from the MES, a little bit of real-time data from the historian. I'm almost down to 1, 2, 3, 4, 5, 6, or about 6 or 7 KPIs just from those points as well. Now, how do we share this out? Okay, so currently it's within Flow. Flow's running the calculations. Flow's executing this model that we've constructed. Every hour, it will go and execute that model again. Very important to remember that this model is a living, breathing, executing model. It continues to go and calculate, and it stores the results of that within our database. Now, I can go and share this data out to other systems. If I go back to my data tab on the right-hand side, where I configured the data that's feeding into Flow, I also have the concept of what we call a consumer to push data out to different systems or to different people. And in this case, I've got a consumer to an MQTT broker because we want to go and feed a potential UNS with this rich information that we've contextualized within Flow as well. So I can open up any one of these KPIs. I can go and open up and extend the integration section of these KPIs. And then I can say, you know what, please go and push my calendar context to my MQTT broker. It will give you the capability to create a payload, a specific payload, and a specific topic format where you can slot it into where you want to push it into your UNS. Okay, we've done this for the Prove It broker for the presses as well. So I'm just going to go and show you guys a little bit. So underneath that enterprise within the Prove It UNS, if I expand the press there, you'll notice that Flow is pushing data out to this UNS as well. So if I expand press 103 there, underneath the production information, you'll notice that there's a 7-hour moving average that I'm already pushing out to the UNS. And you'll notice that the payload is quite extensive. We've included the description of the KPI. We've included what the current value of that is, the start and the end interval of that hour. all the static model attribute fields that can provide more context and more information, we've included into the payload as well. The serial number, the vendor of that machine, some of the nameplate and speed ratings was added. But very crucially, what we do is we also give you two endpoints. We give you an endpoint not only to get the config, which is the model that I've been building on the left-hand side here, but also an endpoint to our API to get the historical data passed through. Now, that data could be from the MES database, that data could have been from the historian, or it could be just the data that Flow now contextualized and stored as well. But Jeff, there's one piece of data that we are actually missing here, and that is data that's not in the UNS, nor in the MES database.
That's right, that extra operational context.
That extra, and that is data that humans can actually feed into the system as well. Now, Flow has this capability that we can add, we call them manual measures. It's KPIs or measures that people can feed data into the system. So let's create a very simple little example, but let's say I want to now know what is the cost. How much does this energy actually cost? So I'm going to go and add a manual measure that's going to just tell me what is my hourly rate of energy. Okay, how much do I pay for energy per hour? I don't want the guy to fill in that number every hour. That's a bit silly to be able to feed me all of that information every hour. So I'm going to make it a weekly KPI. So I'm going to say every week we can go and update our energy cost. So this was going to be my energy cost measure, manual measure. The way that I can see that is with that little human icon there that tells me that's a manually entered point. So let's open up this energy cost. Obviously, this is going to be in dollars or in cents. And initially, I can give it a value that it will just go and track for the weeks. So I'm going to give it a value of 0.4, so 0.04 cents per kilowatt usage. And I can project this into the future. So I can, at the end of the beginning of the week, let the guy fill in his values for the entire week into the future as well. So I'm going to project that into the future. So I've got that capability to provide that information for me for the entire week as well. So what this will do is just create that context. There we go. There's my costing. I can now update this costing manually, and I can utilize this costing now in my calculation. So let's quickly do that. Let's go and create a hourly KPI, because if I want to work with hours, I need to distill the information from the week down to the hourly bucket. So I'm going to create an hourly KPI for my energy cost. And I'm going to go and just say, you know what, my hourly value is equal to the weekly value that the user provides. So I'm just going to set this to my weekly cost factor, deploy this out, and now it becomes a very simple little equation, right? So now I can take my energy cost, and I can go and multiply that by my actual. So I can take my actual here, drag it onto the calculator icon. This is going to be my cost, my total cost. And open this guy up. And then add my costing to it. And then just do a multiplication of that cost as well. So now I've got data coming from the human, data coming from MES, data coming from the historian, all coming together to give me a cost analysis of that as well. And I could have sliced my energy usage per product as well, so that I have that additional context. So I can go and slice that manual data with the product information that I've got as well. Deploy that out, deploy out my calculation, and I should now have a total cost of energy usage as well, based on the manual data that's been fed within Flow for that data. Cool. Again, we can push that out to other systems as well. So there I've got my costing, so I know what's my total cost. I can go and say, well, what is my cost for a year so far? So I can do a aggregate to give me a shift to date, day to date, week to date, month to date, and if I go all the way up to a year to date, I can get my quarters, sorry, and then last one is a year to date number. So if I deploy that, I already have a KPI per product telling me what is my current year to date cost of energy consumption. And it will reset it at the end of the year and then start to track again. What other databases and consumers can we push data to? Well, not only to an MQTT broker, but we can also push data to other databases. So I can push it to a SQL database or a data warehousing solution. I can put it on a Kafka stream. I can potentially push it to another flow system if you have an enterprise flow configuration and you want to do benchmarking between sites. We have the capability to roll up between sites. And I potentially could push it back to an Oracle database or a Postgre database as well, or potentially to some of the hyperscalers. So if I want to push it potentially to a Snowflake database, I can give Snowflake all of this rich contextualized information that's already been contextualized at plant floor and then pushed to cloud to be utilized for potential BI tools or other tools as well. I know that was a lot, Jeff, in a short time, but just quickly wanted to show you guys how from very small, about 2 or 3 points within 2 or 3 databases can really expand this and get quite a lot of information going. Secondary aggregations, rolling aggregations, and then pushing that information out to an MQTT broker as well to really extend the UNS with this contextualized information.
Lenny, you did a great job. And one of the things I just kind of want to point out is that in most of our conversations with most end users, they haven't built a UNS. Yes. They're thinking about it. They like this idea of wanting to do this and try to do it enterprise-wide or site-wide at the bare minimum. Do they need to wait until they've built a UNS for Flow to come in and add value? What's been your experience?
Definitely not. Because we like getting from historical data sources, we can already connect and contextualize data with data that you probably already have in your plant floor. We would like to land the already contextualized data back to the UNS so that it's a nice, easy single point for people to consume the data from, or rather the information from, but definitely not. I mean, you even saw with the capability of adding data manually into Flow that the need for the KPI or to drive that information exists. Doesn't matter if there's a UNS or not. And 9 times out of 10, Jeff, we start without a UNS because we connect. We extend the UNS and we add more capability to the UNS, but the UNS is not a fundamental building block for us to start creating this information and pushing this data out.
Yeah, and I think that's important because what we have found is that we're able to come in on an ROI that is very short. We're talking for a pilot, typically just a few weeks that we can prove that value out. And a UNS project typically is a very long process and you still haven't necessarily shown value. It's now, what are you going to build on top of this centralized data service that is really going to be the value add? So we'd like to meet you where you are. And if you're storing data from the shop floor, then there's a really strong possibility that we're going to be able to help unify that and make it easy for you to not just turn that raw data into better insights, but also govern that process. The reality, Lenny, is that most engineers are already doing what you've shown to some extent for some use case. Where have you found most of that work to live, and how does the business govern it?
Well, easy answer for that is Excel. 9 times out of 10, that work either lives in Excel or it's in some little Python application that someone's done, potentially in a Node-RED or running somewhere. The problem with that is scaling. The problem with that is trust. Which one of those 5 different solutions number do you actually trust, and how do you govern that to roll it out big scale? But yes, Excel is probably 9 times out of 10 where this or potentially it's just a whiteboard in the shift handover room where somebody's just written with a little marker. Maybe there is not even a system, even if it is an Excel, that's even tracking this, all paper-based or manual as well.
Yeah. The beauty here is with the templates, with the ability for someone to actually provide governance around how you're building these models, these rules, your business is ultimately defining in one place how you're going to process this plant floor data. And then you're also governing where it goes next, and it's just automatically arriving. My favorite demo I've ever seen you do is how quickly you actually get data to Snowflake, solving two problems. One, that integration layer between plant floor and Snowflake, because if you're just trying to connect to some old legacy historian and get that data out into Snowflake, you've already run into that problem. You know how hard that is. Flow makes it easy, but secondly, Flow is pre-processing all of this information, saving you the compute cost at the cloud level. Okay, hey, we told everybody that we're going to give you the opportunity. If you want to engage with us and run your own pilot with the team, we'd love to help with that. For those of you that are on the call that have already booked your pilot discussion or request from the Prove It stage, please don't rebook. I have you already on the books scheduled for our meetings. You are secure in a Q2, first part of Q3 timeline. We had 9 in total. We've already met with 5 of you. We've already got those dates planned out, and you have first right of refusal. This is for a end of Q3, so looking at that end of summer timeframe, or planning for Q4. So it's been a really awesome 2 weeks. The overwhelming response that we got from the community, I cannot thank you enough. And even today, great questions, great chat. Please let me take this link. Let's see how well I can do this, Lenny. Let me drop this link in the chat. We might have hit the full capacity of my technical capabilities. Look at that. All right. There you go. tinyurl.com/flow prove it, all one word, in the chat if you'd like to go ahead and book. Okay, we've got a couple of minutes left. We'll take any other questions that you might have. I think we've answered almost all the questions that came in line as we were going. One, I'll just call out, if you have a question, you want to type it in. How many KPI calculations can Flow handle? When we query and calculate data for days, months, etc., it can be very busy, I imagine. Does Flow use clusters of servers? Essentially, scalability question. So, really unique things about Flow. I just want to quickly say that Flow got its start on the plant floor. It's a bunch of process and control engineers turned software developers, and we're now 10 years old as a company, meaning that we've seen it all at this point, or at least we think we've seen most of it. For scalability, all of those engines that Lenny was describing, based on the license that you choose of Flow, you have the capability to create multiple instances of those engines. Those engines can also, depending on the license, be distributed onto their own hardware. Those engines can run in Docker, they can run on a Windows server. You then have the ability to obviously scale vertically and horizontally, and you can take your events and your KPIs and you can dedicate them to specific engines and resources. Really helps you prioritize if scalability becomes a bit of an issue. We haven't run into it being an issue yet with that architecture. Some of our installs are running more than 300,000 KPIs and events per day on their Flow system. So we feel confident that we will take care of scalability. The template servers can be hosted on their own machines as well. So with a Flow install for each of your sites are reaching up to the template server and you're governing those templates from a single point and then deploying those templates out to your instances.
Another design capability that we added into the product is exactly that as well. We don't want to go and query a historian for days and days and days and months worth of data when we're backfilling or creating some of it. So inherently in the product, we've designed capability to batch backfilling. So We will not hit a historian to give a year's worth of data. If I want to do that, we will batch it into chunks. Another important thing to notice as well is that if I already have the hourly data contextualized within Flow and I want to get a daily or a weekly number, we're not going to hit the historian again. We hit the already aggregated data in the Flow database. So we really try to optimize that process of collecting data from source, trying not to overload that system, and utilize the aggregations that we already got to further the calculation stream or dependency stream upstream. So it's really efficient in the design as well.
That's right. And Lenny, with that, we are at the top of the hour. Everyone, we will have this recording out to you in the next 24 hours and cannot thank you enough and look forward to connecting with you and hopefully taking the next step on the beginning of your Flow journey. Lenny, great job and thank you.
Thanks, everybody.
Have a great day.
Bye.